Okay.
Mostly
Hello?
Yeah, so beta breakers is a race from the bay water side to the ocean water side, right?
Nice.
I should say it's a race that it's a very uncompetitive race
Yes.
in the sense that usually about a week in advance a map goes out. I've already seen one that shows you the location of the liquor stores on the way. So it's more of a ramble, a beta breakers race. My oldest has run it, but I think the number of runners is really a minority.
Right.
Yeah. Costumes are encouraged.
Oh yeah.
So everybody runs in a even the runners.
Wait, are you talking about the Superpower 5K?
We're talking about the beta breakers.
Oh, never mind. I'm so sorry. I'm here in Toronto, and down on the Toronto Islands.
Oh, okay.
Little like nice little blob of lands over in the lake, and you got to take a ferry to get there. They're having a superhero like costume run as well. I don't know what I want to dress up as. I have an Iron Man costume, but obviously I'm not running in that because it's made out of Eva foam, like styrofoam. But
Sure.
that's like walking with like a turtle shell on you. So
You will see a lot of those as beta breakers.
a lot of Iron Man.
A lot of turtles. A lot of elaborate shells.
Elaborate shells.
A lot of
Yeah,
sorry. Yeah. I mean, we'll go down to the Panhandle, Golden Gate Park, and just watch the people passing. It's like just people watching, the costume watching. I mean,
Well,
do we need to walk it ourselves? Nah, I think I get it.
yeah. I mean, it's just really fun. I mean, this is my first time going to a race in Toronto. Especially I think it's like one of the few first in-person races. There's also the waterfront, so the Toronto waterfront. That's like the marathon. I'm training for that as well. So that's in September. Yep.
Wow.
Yeah, I've run marathons before. I'm from the United States and I'm living in Toronto right now. So back when I lived in Indiana, I did the Indy Marathon there. So yeah.
So I saw a video just around holidays that a professor at University of Toronto took a EEG system underwater. And has the whole thing on YouTube. I'll try and find the.
Wait, which one? Do you remember who it was?
Well, it was John Griffiths was there.
Yeah, he's my PI. Yeah.
Oh.
Yeah.
So have you seen this video?
Yeah, I think so. I think I know the one you're talking about.
Yeah. It's like, and there's snow everywhere. They're yeah. Anyway, I'll let Bradley get started, but that's awesome. John, I saw a bunch of posters come out, so I want to see which one you're maybe involved with.
Yeah, that's great. Welcome to the meeting. Thanks for attending. Hussein is here, so why don't we get started? Why doesn't Hussein introduce himself to the rest of the group here?
Hi, nice to meet you all. So I guess I kind of semi-introduced myself. I'm a PhD student at U of B in medical science. So my PI is John Griffiths, and so I mean it's in my PhD's in medical science, and as you know, the name of the PhD is kind of it's just about the department that I work in. So I do research and I do computational neuroscience research in our lab of whole brain network modeling. And right now I'm actually studying the connectivity structures underlying schizophrenia using some new methods and techniques in dynamic causal modeling. However, our lab just extends to a lot of different areas, like the applications between AI, cognition, even getting into a bit of like neuroethics type of research and writing on the nature of the brain-computer interface and how, and it's just how these topics and ideas extend into greater theory. Okay, I honestly can't remember exactly how I came across this Slack channel, but I became interested in potential GSOC projects, and I actually, I've actually previously spoken with Jesse a bit on Twitter and social media with Jesse Parents, and I applied for the GSOC position here in the orthogonal lab. So, in addition to developing my proposal, I've been trying to get familiar with Netlogo. Hopefully I should be ready to get started at the latest June or like mid to late May. So yeah, and yeah, Toronto is really nice and lovely this time of year. Can't say it's always like this, but right now it's really really warm, really pleasant. Yeah.
Well, that's
Awesome.
great. Yeah.
Yep.
And yeah, go ahead, Morgan.
Well, I was just going to say, Bradley and I talked yesterday, and John is the guy that I was talking about in terms of the PI behind EEG notebooks and
Yep.
a number of other projects. Are you doing virtual brain stuff, or are you using like Neuralib or something in terms of your own computational neuroscience work?
Yeah, I'm using
Sorry, I don't know if this is of interest to everybody.
I've used Neuralib maybe like once or twice, but right now my current project is we're actually using SPM 12 for the dynamic causal modeling method.
Did you see?
As for the virtual brain, we are comparing we are comparing the dynamic causal modeling techniques to those say nonlinear methods like the virtual brain and
I think more people should be using DCM for EEG analysis. I mean, you do any EEG modeling or TMS modeling, or
it's EEG modeling. Yeah.
Okay. Yeah. That's
awesome.
TMS.
We are working on like bigger projects with TMS and RTMS as well. So, we don't we're not pigeon. I mean, not me, but I mean, not sorry. When I say we, I mean everyone in our lab, right? But like, that's not my thesis. So that's not my main project. Yeah.
I just saw like 6 tweets from John outlining posters that came out recently.
Yeah, they're presenting at one of the conferences up here in Canada. So
yeah, it's like neurology conference or something, but or NeuroSim. But yeah, that's great. So
thank you for the invitation. Thank you. It's really nice to be here.
Yeah, welcome. Yeah, and I know that Hussein and Brian applied for GSOC, or the project on open source ethics, and so I don't know. I think they'll be making the decisions on the 20th, or they'll announce the people who were selected. I've been, talking with INCF, and they're seeing, they're doing this weird ranking thing this year. But other than that, I don't know anything. But so I want to do a group that's independent of what we're doing here, which is this idea of having open source data sets and looking at some of those things that we can, use for this type of approach. So, we talked about agent-based modeling, and that's a nice approach. But there are also data sets that one can use to, do a similar thing to what we talked about with using agent-based modeling. So this will be a group where we maybe talk about agent-based modeling, talk about data sets, talk about different types of data analysis that might be useful for understanding some of this. And I guess, we could talk a bit about like the brain and neuroscience as well. I think that's bringing that in is, always, Morgan likes that idea. So that, we're going to start doing that on the 20th, next Friday. I have a time on Friday. For me, it's late morning. So it's like 12 o'clock noon Eastern time. And we're going to try that slot. And I have a couple other people interested in it. So
this is be focused on open data sets.
Well, yeah,
specifically for kind of graph neural network analysis. Well,
it's actually for this open source ethics project, and some of the data for open source communities and things like that. Now we'll probably get into some of I found that there are network data sets for this, and that network theory is a good way to go in terms of analyzing communities, open source communities. But I mean, I didn't include that in the GSOC project because I think that's a little, it might take too long for a GSOC project. But it's something we can talk about in the group because I think it's a useful technique. And of course, with networks, you get into all these associated issues that tie into like brain networks and other types of approaches. But yeah, so I mean that's and I don't know how long we'll be doing that, but I think it's a good topic and something we can explore, and hopefully we can build off of that. So okay, so I wanted to get some updates from some of the interns. Looks like Amanda and Samantha and Brian are here. So who wants to start?
I guess I've got my camera on so I can start.
Okay.
So I've been just starting to put together the beginnings of a possible computational model, or kind of flailing in a direction of a possible computational model for collective cognition for the GSOC project. So I've put together kind of a presentation of where I'm at right now. If anybody wants to see that, I can do that later today, or just sit on it. It's something that's definitely in development. It's always helpful to present in these groups to get the feedback, to see where it's way off or dead on. I've also reached out to Mick Ashby just to say that we're working with his paper and that we're excited about his research, just to see if he has any thoughts. It's just kind of a personal thing. But other than that, I'm just excited to be here and having a great summer so far.
Oh, great. Yeah, I saw your update. You were happy to be done with your usual school year. Now you're doing your fun research or something.
Exactly. Yeah. My whole family's like, aren't you done with school? What are you doing? No, this is the fun research now. Now I get to do the good stuff.
Yeah. Thank you for the update. Oh, go ahead.
So can I ask what kind of data you're modeling?
Sure. This is in reference to the project that Hussein and I have applied for in GSEC. So we're modeling basically ethics and sustainability across open source communities. So there are several different types of data sets that would apply here. And this is part of why I'm really excited to do this group that we're going to be doing every Friday, because I've thought about this in terms of data from Slack, from GitHub and other social community platforms for collective cognition. I mean, is the fun way to say it, right? Well, yeah. Ooh, interesting. What's that face?
Well, well, again, so I can imagine, GitHub commits, or and messages and things like that, and following, and is it that data, or what are the kind of community metrics that you're using, or that you're interested in predicting, or that's what I'm trying to get at. Yeah.
That's a great question, and so that's why I was starting with that data set, because that's kind of the most concrete ways in which we can think of measuring this, right?
And by that, you mean like Slack and GitHub and things like that?
Yes, at least initially, because the other metrics or the other things that I'm particularly interested in are interviews with open source organization leaders and members, and trying to figure out how people, and this is in my presentation later, trying to figure out what are the contextual elements of these data sets. So there's concrete, empirical, and quantitative data on what exactly is happening inside the community, but then kind of it's nested within kind of this ethical contextual information or ethical contextual data set that will be expressed a little more abstractly by necessity, because you can't really quantify such things. So this is a great question.
I mean, maybe just confirmation that the ethical part is the bit that's hard to quantify. You know, because again, like I mean, there's a certain aspect that could focus on kind of like the, I don't know, I don't want to say like the management quality, but like, you know, like the number of commits, the number of, or you know, like the productivity of the commits and the messages. Well, you know, like I'm trying to, you know, well, again, like I'm trying to get at what you mean by collective intelligence.
Yeah,
right?
No.
You know, separate from the ethical problem, right?
Yeah.
And you know, so like what is constituting, you know, the collective, or
that's
the metrics of that. Yeah.
Right. I mean, something that I've been now you're just making me want to bring up my PowerPoint. So maybe I should just wait to address this.
Yeah.
I do have one specific answer, but I think there are many.
Yeah, we'll do this after the update. So Hussein said he couldn't stay for the entire meeting. So yeah, if you need to leave, you know, you can leave. We usually have people coming in and out. So. Oh yeah.
Yeah, just wanted to let you know.
Okay. So Samantha, do you have an update?
Yes, Mark. Can you hear me okay? I'm on.
Yeah, I can hear you.
Yeah. So this week I don't have a big research update, but I did finish that proposal for that project I presented at the research showcase a couple weeks ago, and I was going to send it to you and Jesse later today. If you wanted to like read it and give me feedback on it, I'd appreciate it. But for this project, I'm finally done with my semester, so I'm starting to put a lot more focus on it, where instead of dividing my attention. But that's kind of my big update.
Well, that's good. Yeah, you're making progress, as we've said, and yeah, we can take a look at that. It's always good to get some feedback on things, so please do.
Thank you.
So Amanda, and she put an update in the chat. So update. One short-term goal I have is to write a bit about part 1 on becoming aware, and this is the book of Varela DePraz and Vermesh. So we're doing the Cognition Futures reading group, and we're going over this book on becoming aware. And so we're kind of going through it chapter by chapter, and you know, we're kind of getting into it every session. So okay, yeah, let's write a bit about part 1, which we've been working through in this reading group, linking it to other things that have come up in the group, including Chamaro's work on synergies. I've also been reading a book on the philosophy of madness, the author's preferred term for psychosis. Okay. And it's super interesting so far. I'm very interested in the cognitive science of psychosis and other psychopathologies. So thanks for the update. Anyone have anything to say about that? I know that Brian joined us and Jesse in the reading group. Yeah. Okay, thank you, Amanda, for the update. Right. So, I don't know if Morgan wanted to give an update.
It's this week, not much on the nothing really on the organoid front. There was a real tour de force paper on single cell transcription of the entire body. So 27. So I didn't drop a link. I feeling like the organoids material was getting a little diffuse, but super important, right? So they're doing this. I think they processed like 40,000 cells, but of 400. I think it was like 400 cell types, and 20 plus organs, right? So you're seeing, like the differential genetic expression across all these tissues, and of course, the wonderful thing about focusing on the brain is that it recapitulates all that complexity.
Yeah.
In itself, which is why you have things like the Blue Brain Project, and which is still, which we shouldn't forget is still continuing.
Yeah.
Still publishing great stuff, and by that what I mean is like somebody who's focused on like a millimeter cubic,
Right.
and just continuing to kind of zoom into the fractal set that is neural expression. That was I really appreciate Bradly and Jesse having time to meet yesterday and catch up on some things, and just wanted to say, if people are interested in neurotech projects, please do let me know. I'm sorry, we lost Hussein just there.
Yeah.
But there's the neural challenge that I told Bradly about yesterday, which is this collect data from home using a consumer EEG headset or NIRS headset, and John Griffiths leads a team of other NeuroTechX people that developed this package that allows you to you have a bunch of crafted experiments that you can already run on yourself, and then because those come with the package, everybody's kind of collecting that, so then they can pool their data together. And some of the groups that are involved, either their companies or their research labs, so they've already got kind of built in a number of people using it, so it's also a great way to get your feet wet in terms of learning about the kind of EEG processing, and so we bill it as a great way to actually introduce scikit-learn.
Yeah.
And as you get more and more kind of advanced with it, then you graduate to MOAB, which is the mother of all BCI benchmarks, and which is very much built on scikit-learn, but is focused on this reproducibility measures and comparison of algorithms, and really takes it to the next level in terms of best practices on all this stuff. So again, a great way to learn, a great way to get into machine learning and the nitty-gritty of prediction with what is what a lot of people find a kind of exciting data to play with, but especially if it's also coming from your brain.
Yeah.
So it's neural-challenge.com, and now I'm checking that before I write it.
You can put it in the chat.
Yeah, I'm just
Okay.
I'm checking that goes somewhere.
Oh, okay. Yeah. We've talked about using secondary data sets, and that's an example of something that. Right.
Yeah. So Moab is a real project that already collects open data sets. And so when you test your algorithm, the great thing about Moab is that it's testing it across multiple data sets.
Okay.
So, what we're, or, so the people who created this, right, were different people like, sorry, he's now at Facebook Meta Reality Labs. He went through Control Labs, so he was working on the EMG device.
Okay.
Anyway, it's a great project because it really does pull together multiple data sets and use kind of the best practices on that. Like, we're not just comparing an algorithm against another algorithm
Right.
that you've had to write yourself, right? On a single data set that you've collected yourself and nobody else has tested against, right? This is, you get to test it against 10 data sets that have been used by other people, and you get 8 implementations of kind of best algorithms to compare your algorithm against, right?
Yeah.
And and what we certainly hope is that it would be an amazing data set for network science as well, right?
Yeah.
As you get to the kind of high density EEG data sets that we can collect with the high end equipment.
Yeah, I think that's good.
That wasn't. I'll find the right site, Brian. Just.
Yeah.
Yeah, thanks. I'm trying to find it. I know what I posted is not it.
It's. I'm just gonna go to John's Twitter.
Yeah, that's what I'm at. Yeah.
It was like March. It's like March 27th, 28th. So anyway, I'll update.
All right. Well, thank you. Now, if Brian wants to give his presentation, we can do that. Or just, it doesn't have to be too very formal.
Sure.
We can just go through slides.
I was just in John Griffith's Twitter back in the March area. So yeah, let me pull out. Yeah, I would love to give my presentation really quick because I think it'll go by quicker than it took to put together, which is always the case. And I think, Morgan, I'd love to hear your thoughts on this because I think you were asking the questions where I was like, yes, that is the best. That is the question, right? So let's see. Oh, that's the end. Let me go back to the beginning. All right, this is a preview of the whole thing. Okay, so can you see my screen and hear me and everything okay?
Yes.
So, when this project was originally proposed, it was kind of proposed as a model of ethical sustainability, like kind of a way to avoid burnout in open source communities, a way to encourage participation across all community members. And so that's where it started. And collective cognition has always kind of been part of it. And I think that's something, especially with regard to the INCF, that is really exciting about the project. So that's why the question you asked earlier, Morgan, like what are the metrics for determining ethical cognition, like what across communities? I mean, I'm paraphrasing, but yeah, that's really the interesting question. So where I'm at with it right now is that my proposal has 3 phases, and I'm only going to talk about the first one because can't really do the other 2 without getting the first one really figured out. So the first phase is to build a computational model of collective cognition within open source communities. I'm going to build on existing theoretical actualized models as a kind of a starting place, and that's where we'll really get into. That's what we'll get into first. Then talk about different hybrid classification models, like using sub-symbolic and symbolic methods to construct kind of something that's that both takes advantage of the technologies we have to model learning in a computational way, without being a black box or without losing transparency that's required for ethics. And then per what Amanda was talking about, we've had this wonderful Cognition Futures reading group going on for a while, so been really digging into embodied cognition and ways of kind of computationally considering awareness is kind of the thing that I've been getting out of it that has been really exciting. So part of that is to make experiential knowledge our motivating factor, or the primary source of kind of our metrics for determining whether or not how we're representing our data and how we're representing our communities, whether or not that's working, how it lines up with experience. So anyway, I'll say more about that. Then the other two phases, which will come after the model, are a multi-agent simulation in Netlogo. So that's been, me and Hussein have both, it sounds like, been digging into Netlogo and trying to figure out how to do that. So that's really exciting and really looking forward to learning more about that. And then finally, the thing I'm really excited about with regard to this project is making a web-based auditing system for open source communities. So this is my first response to you, Morgan. Like kind of seeing if we can take in this kind of more quantitative data from a community and enable someone to go to a website, give access to their Slack and GitHub repositories, and then have the model run to kind of simulate the sustainability or the ethics of their community and their participation within it. So that I really want to make something people can use to kind of investigate themselves and their communities. I'm not sure if that's really the best way to go, but I'm always excited about real-world uses of abstract conceptual simulations and computational models. So starting points for this model that I've been thinking a lot about have been, of course, Nick Ashby's ethical regulator theorem, but also a paper by Peter Kraft from 2019, which tries to model collective cognition by assuming a setting of a finite time horizon, decentralized, multi-agent, partially observable Markov decision process. I'm not going to try to say that 5 times fast, but it's I'll go into the mathematics of that in a second, because that's what really excites me about it, is that this answers your question really concretely, Morgan, about what are we really considering when we talk about collective cognition. And I think that the DECPOMPTIV, I don't really know, it's a terrible acronym, it's got to get a better one. I think this provides us with a possible objective function for such a model. And that objective function basically looks for a reward function, or in this case, you can see here an expected reward function that you try to maximize for the entire group. And this is kind of an Olson kind of old school look at computational modeling of cognition or of group behavior. I think it has some problems, but I'm excited because it's concrete. So it seems like a good place to start, especially in combination with the ethical regulator theorem. So let's see, yeah. So specifically what it does is it takes a set of possible actions, which would come from the contextual and experiential data we would gain from interviews and from real-world experience, and then the state of the world or the organization, and finally the reward function and its relationship in time. And I wrote here error function. I'm sorry, that's wrong. It should be expected reward function, or just expectation. That's wrong. It's a leftover from my machine learning class, I think. There we go. So my goal is to just combine these two things. So to use this objective function as kind of an activator for the way that truth informs intelligence, informs influence on the whole system. So it provides us with kind of a mathematical way of representing this stuff computationally. Finding myself unable to talk about this very clearly. I apologize for that. So I'm just going to leave this here for a second and move on to the 9 requisites of the ethical regulator theorem, of which the first 6 are just said by Ashby to communicate like an effective regulator, and then these last three are what makes that regulator actually ethical. Yeah, I'm influenced by models like ACT-R and Clarion from Ron Sun and other hybrid models. And I think one thing, I talk about this a little bit later, but I think one thing that's important is that in ACT-R and in Clarion, useful knowledge is usually true, although true knowledge is not necessarily useful. Whereas for Ashby, the ethical regulator does not require perfectly accurate information, but it must be sufficiently truth-seeking to be able to cope with uncertainties, minimize the impact of unreliable information, misinterpretations, and deliberate misinformation as best it can. I think that's worth noting. And then, I just copied this entire thing in case anyone has any questions about how Ashby defines truth, because I think that's a very crucial part of the ethical regulator. I'm not going to read this entire thing, but it's there in case we need it. I anticipate a lot of discussion about this. So I mentioned hybrid models. I think something that excites me about the simple computational model from Kraft is that it enables us to use stochastic methods to construct a model. I've talked a lot about deep learning not being transparent in my research for REL in the last few months. However, because we have these stochastic methods, it's so tempting to kind of apply backpropagation and other kind of less transparent methods to integrate our model or to allow our model to work the best that it can given the technology that we have or given the innovations that have been happening. So hybridity is a big question. And then we come to the macro organization of the model. And this is something Ashby gives as an example, but I think another paper that Bradly shared recently, the computational ethics paper, has a reflective equilibrium model that maybe will be more helpful as a macro structure for the computational model that we're building. So how would we do this? I'm really excited to reach out to open source communities and interview organizations about what they consider ethical behavior to be and to build our action sets to use in our objective function. Specifically looking for unambiguously prioritized goals that the ethical regulator theorem needs to work. So here's a few example questions that I've started putting together. I love these drawings of cybernetic orders. That's mostly why they're there. I just think they're so cute. But really, this is the more important or more pertinent thing to note, which is that I think what we'll be building here is a third-order cybernetic system or cybernetic system with an eye towards the possibility of a super ethical system. I don't think that will break past level 3 in the next few hundred years, but it's interesting to note. So yeah, I'm kind of looking at combining this ethical regulator model with this reflective model, and then sticking it into Netlogo, running simulations, tuning the model, and then finally in our web auditing system, kind of making sure to integrate cascading levels of analysis for maximum transparency across roles in the organizations and the ethics thereof. So that's my presentation. That's where I'm at right now. It's kind of crazy, right?
No, that was great. That was great. I did have. Why does the 1 through 6 scale end so dystopically?
Right. Here, let's see. You mean 1 through 6?
No, it's color coded.
Oh yeah, that's right. So Ashby.
Yeah.
Ashby in this paper, it talks a lot about kind of a Nick Bostrom kind of gesturing wildly towards a dystopian future, and he's trying to avoid that. So
there be dragons.
Yeah, exactly. And beyond this level, there be dragons. And I think he says in his paper concretely that by building third-order cybernetics ethical systems, we can start to put checks and balances on 4 and 5 to avoid 6 in terms of these levels. So I think he's kind of blowing his theorem up to its maximum size.
I see. It wasn't so much dystopian as a style of presentation.
Exactly.
Okay.
Okay. It also provides a lot of inspirational quotes from Martin Luther King and Gandhi and other.
Gotcha.
Sure.
So the computational models certainly, somewhat familiar, or certainly, the first model that you had up is definitely, these are super popular right now, right? I mean, the decentralized, I think, would be the kind of the novel thing. Sorry, that's kind of a question. I mean, how new or how much work has gone into decentralized, what I assume is multi-agent, what we would normally see as multi-agent reinforcement learning.
Yeah, exactly. So that's why I kind of got excited about Peter Kraft here, because because I never run into his work before, and so 3 years ago he explicitly laid out this model for decentralized multi-agent, but using Markov chains, which is something I really have a lot of experience with. But it's also,
sorry,
as you were saying,
yeah. So just so you know, that's actually my background.
I love it. That's great.
I'm used to just waiting a really long time. That was what we used to do back in the 2000s. Before GPUs and deep learning, we just clusters and really long wait time.
Yeah. So I think that's a big question that I have, is kind of how to put this model into practice. I think that's a huge question.
I mean, so there's no existing implementations. I'm not going to be able to find papers with code on a decentralized Markov decision process.
I haven't found it yet, but I assume it exists. I mean, this paper only came out about 3 years ago, and I just started digging into it recently. So, but that's a big question that I would also like to know the answer to.
Okay, I mean, so I love this in the sense that this is what computational psychiatry people are using to do their modeling of behavior.
Mm-hmm.
These are popular models for that. And then I'd love to also point you to this conference that was last fall in India that was focused on ACTAR plus got 6 other kind of computational packages and had their authors or PIs do a talk on them. So it was basically a focus on these kind of computational behavioral models.
Do you remember?
Not necessarily.
Yeah.
I'm gonna dig it up, and so we to make this. There's actually a NeurotechX India meeting going on right now. It's their evening, and but I'll check in with them to remind me of the. Our Slack is not paid. We use the free Slack, so our messages disappear. We get we have a 3-month kind of moving window.
Oh no.
Yeah, I know. So it's if you go for too long, I lose messages. But I would love to talk to you about that. Or there's a lot of other examples, and these are active communities. and one of the things that came up when we were talking about that meeting in India was this recent initiative. So it was Jonathan Cohen at Princeton and Tal Yerkeni, who is at UT Austin, but I think he was doing a sabbatical on Twitter. I haven't checked in. I don't know what this Musk thing means for, I think a lot of academics might leave. But they were putting together an initiative to harmonize computational behavioral models across packages. And there's they have an NSF grant to do that. So those would be good. But I would return to the same question, where it's I've certainly wanted to do things where it's pulling out hierarchies from an email database or something like that. So plus say commit history, you could get at again, kind of I don't know if we want to call it productivity or something like that. But it seems like the next level for ethics would be again, not the next level necessarily, but the next level that you could kind of operationalize would be is everybody being able to contribute, or and reading a Florence Nightingale story to my daughter last night. It's the tagline is she not gets the best out of herself, but she gets the best out of everybody else, right? And so it's you want this decentralized structure to somehow all boats rise, or again, I'm not sure what it is, but that's my question is what metrics would you use to show that diversity and multiple viewpoints and multiple opportunities are happening.
I think this is great. And I know, Morgan, you said that you wanted to present on a mathematical model. That'd be great to follow up on this. Just a little bit of it could be more of a commentary if you want, but I mean,
Well, so yesterday we talked a little bit about, I was trying to give myself a small bite-sized project so that I could have something to present for next week, and I wasn't sure in that Gary Marcus chain Twitter thread that from last week, that was the day before last week's meeting, whether there was something in these ethics of large language models papers that actually computational, and I was mentioning it to I was feeling bad that all my examples are drawn from psychiatry, but I think it's it's a great area to set the bar high, and one thing we would want, we've proposed having patients converse with an agent, right? Not necessarily, again, this is mainly about scaling psychiatry to meet demand, not necessarily criticizing psychiatrists, but it was really what we're trying to elicit is a lot of structured speech from subjects, right? So it is what we want is the agent to maximize the complex structured speech that the subject is capable of producing, right? And we want 5 to 10 minutes of that, but we also want the agent to only suggest, like all those comments from the agent need to be positive, supportive, and never never no harm.
Yeah.
Like what the sorry, go ahead.
So I would like to hear more about that, but I'd also like to follow up with some things that from Brian's presentation specifically. Yeah, sorry that I missed the start of that, Brian, but it looked really great. I know you put a lot of effort into that. Let's see. So yeah, cool. Sorry, also I missed the earlier part of things, but what were you? There was something I was gonna ask you, Brian. Sorry, hold on a second. I'm still recovering. Hi, everybody. I'm still kind of recovering from my illness, so I'm a little bit foggy-headed. Yeah. Yeah, sorry, I didn't mean to interrupt the whole chain of things. So what was happening? So I guess it was Brian's presentation, and then what are we doing now, or what's going on?
Oh, I guess we're gonna probably move on to other things, but I wanted to elicit some conversation on this a little bit because I think it's
Let's do that.
Yeah. So I think it's really interesting stuff, and I haven't really given a lot of background. Well, I've been working on an open source community course or some course materials for this. So this is kind of the impetus for some of this other stuff that we're getting into. So this is how this sort of came about, this whole project. And so, I mean, one of the things about open source communities is it's very hard to sort of elicit a lot of contributions. I mean, if you have like a contributor base, it's easy to optimize for that, But when you're trying to start from scratch and you say, you have a community around something and you want to start building expertise and you want to bring people together, then, how do you sort of bootstrap that self-organizing process? How do you get people to come in and, there are probably things like top-down things you need to do first, but we don't really know what that is. So that's one thing is, building from scratch. And then the other thing is that sometimes things aren't really optimal. In a lot of systems, I've done some talks on what we call sub-optimality, which is where there's, we like to optimize things in science and in especially like in machine learning and things. But sometimes there are things that are purposefully suboptimal. And then why would you want to have something that's suboptimal? Because sometimes optimization puts you in a place that you can't escape from. So like what I'm thinking of is like, say you have like in evolution, if an organism optimizes for something and then the conditions change radically, that organism then cannot change, to something else. It's kind of stuck in a hyper specialized set of traits. And so, but this is the thing about suboptimality is that's I guess it's maybe kind of like generalization, but it could also be thank you for that. Yes, you're spying on me, my research gate. But the basic idea is that suboptimality allows you to get out of these sort of, I guess you could call them local minima or local, and so you can escape them more easily. And it's a little bit different from generalization, because being a generalist is sort of like not really committing to anything. Suboptimality would be where you commit to something, but it's not optimized. So it's kind of loose. And so, as a consequence, say like in an open source community, you could bring a group of people together to do something very loosely, and then they could reassemble for some other task, and then reassemble for some other task. And it's purposefully suboptimal in that you don't have like experts engaged in like, this, you don't have the best experts, and then like, you have the best experts for this other thing. And typically in open source communities, you don't have like the best experts for something, or they don't commit to, a year or 2 years of training. You get people who come by and say, well, I have time to do this thing, and I have some expertise, and I'm gonna work on this problem, and then it kind of hits, and you gain expertise through that, but it's like it's not optimized for the task. So I mean, that's what I'm thinking in terms of how this might work, but I don't know if there are any good mathematical models for that. Maybe just stick to optimality for now and just say we'll assume an optimization model, and then see how well it works, and are people really optimizing. And that's actually part of like the idea of heuristics in cognitive science, is that people don't people kind of use heuristics to get through things. You make a best guess at something, and then you just do it and see how it works, and then make another heuristic. And so I mean, those are things that are there. So anyways, I just wanted to bring that up because I felt like it was important to think about.
Yeah, I love this idea of suboptimality. This sounds great. I can't wait to dig into this presentation more and try to integrate it into, because how would you integrate suboptimality into a computational model? That's something.
Yeah. Well, I mean, I can't remember exactly. Go ahead.
Well, I was going to say, like, that's the first thing that I feel like I can do. Like, all these other things seem hard, like suboptimal.
Yeah.
Like, that's my bag. But honestly, like, something, a policy that degrades behavior, like, that seems easy, right? No, I love it, and plus, this if you look at just mathematical optimization, right? Like, this is again, simulated annealing and other methods speak to Bradley's point about when this is all framed as an optimization problem.
Right. So I mean, I don't know how you might approach this in every case. In the case that presentation you put in the chat, there is sort of a very, you have to be very operational about this, and you have to like kind of pick a model and demonstrate it. So in this talk, we demonstrated it using sort of a cybernetic model. So the idea would be that you'd have this, you're trying to achieve some sort of feedback loop, and then the optimal, well, actually, let me do my board here. I think this will work. So let me share my screen. And, okay. You can see my screen. Okay. So, an optimal version of a positive feedback loop might be something like this, where you have like a small number of components, and you have this closed loop first order feedback. All right. Now this is, let's say we wanted to discover this from like a bunch of options. So we might run an optimization algorithm, and we might get to this motif here where you have these two boxes, these arrows, And basically it's describing a first order closed loop feedback where you have this this node A, this node B, and A is passing things to B, and then B is passing things back to A, and then there's an output, and there's an input into A, which is whatever it is you want to transform into the output. So that seems so that's optimized, and that would be an optimized description of a closed loop first order feedback. Now, suboptimality in this case, at least in the presentation, is where you might have like A, and then you might relax this assumption of optimality, and you might end up with a couple of different options or a couple of different pathways. Okay? And then you end up with an output that might be heterogeneous. So you might have a feedback from B to C, you might have a path from C to B and a path to C to A. So this looks a lot more complex. Now, the way we got this B as opposed to A is we relax some of the optimality assumptions. But look what happens here. Now you have a system that isn't stuck in this simple set of pathways. I guess you have a first order closed loop feedback in some sense, but you also have the possibility for open loop feedback. And furthermore, you have other alternate pathways that you can take. So let's suppose that we were operating under the assumption of A, and we optimized our system for A, but at some point it turns out that this pathway was eliminated. And I'm thinking specifically of like in evolution when you have something like a gene regulatory pathway, or there are other options like in social systems where some pathway is closed off. I've done, and in social insects, ants, when they build their colonies, they follow pheromone trails. And one of the cool things you can do with pheromone trails to be kind of mean, but not too mean to the ants, is to lick your finger and move your wet finger across the pheromone trail. You can tell where the pheromone trail is because the ants are following it. When you do that, you remove their pheromone, and the ants will. So this is the trail, and these are the ants, and they follow this trail, and you cut the trail. So what happens when you cut the trail is the ants lose their orientation, and they kind of like mill about right here. And then they start to move out around this cut. And eventually they kind of find the other side of the trail. So they're laying down pheromone here, and they're doing some exploration. And then they come back to the trail, and they continue on. I've seen this happen. I've watched it. It's usually, it's kind of one of these processes where they're optimizing locally or something. They're on this pheromone trail, but there's this need to explore the area around it once you cut this. Now, in a system like an algorithmic system, if we were to assume this was optimized by an algorithm, you don't have that type of free exploration. And in fact, I know that some of you have seen Ankit Grover's work on switching in algorithms. And this is kind of what he's trying to do is he has like an algorithm that goes into an optimum, and then he wants to pop it out of the optimum and then get it to some new optimum. So this would be the new optimum, this would be the old optimum, and this would be the exploration or the switching, where you switch the environment or the fitness or the algorithm or some aspect of it to pop it out of that optimum and then move it to a new optimum. This exploration process would be necessary because you're moving it to a new optimum. You want to find that new optimum. And hopefully it's better than the old optimum. But in any case, this B, if we look at A and we say we cut this connection between A and B, then suddenly this closed loop feedback becomes untenable. It dies and you can't use it. Nothing can be passed from A. So A is accumulating everything. There's no feedback. And more importantly, there's no output. For B, though, if it cut this A to B, and that was removed, then you still have this pathway from A to C. And you still have this feedback from C to A. And you still have this pathway from C to B. And most importantly, you still have multiple ways to get an output. So this feedback becomes an operative, this feed forward becomes an operative, but you still have other path. A to C becomes, an option as well. So these things are all still operative. So this design, looks, and actually you can't get from A back to B. So when this would be removed as well. But the point being is that you wouldn't have a feedback in this system, but you would have a feed forward, and it would be a circuitous path. So the idea, though, is that in these kind of systems where you have suboptimality, where you relax the optimization criterion on purpose, you have more options, more pathways through the system. And then as you have more pathways through the system, seed A would still be around. But anyways, it doesn't really matter. The idea is you have more pathways through the system, and it's more robust, what they call robustness. So I know a lot of you have heard of this term, but it's something that is very important in complex systems and in evolutionary systems. And so robustness is the key here. We want to create a system that's robust, and to do this we have to relax this optimality criterion. It allows us to generate more potential pathways, but not too many. We want to still eliminate superfluous pathways. But in case conditions change, if things get cut off, if things become if things become inoperative, then we can have this still have an output. It's still operational. So that's my little spiel on that. I think it's that's the way we approached it in that talk, and I've done other things on it as well. And there's this idea of people have done computational studies in evolution where they've looked at hypothetical gene pathways, and they say if you mutate something, say you mutate some pathway or some part of a phenotype or some gene, something becomes inoperative. You can, but if you have multiple pathways, that won't become. So people have talked about enzymes being the product of multiple genes, and if you mutate one, it may shut down the enzyme. But if there are multiple genes controlling the enzyme, then the enzyme doesn't get shut down by some random mutation, and you sustain that function. And so this is what they call robustness, and it's a very important concept, I think, in complex systems, no matter what the system. It's just this idea of having multiple options available. So I see that there's some links in the chat here. Okay. And so do we have any questions about that?
Is there, you said you had robustness there. Is there another term for it? Because it's not suboptimal, right? It's actually, it's what are you judging it by?
Right.
It's just how you're giving it that criteria, right?
Yeah.
So it's why are you seeing this with so many, with multiple complex systems? Yeah. Right? Is that this is better, yeah. Right? So, is there a different term for it?
Well, I think when I say suboptimal, I mean
other terms for it. Sorry.
Oh, well, when I say suboptimal, I mean locally suboptimal. So we're always evaluating the optimality in terms of local, that feedback motif. That's optimal in that case. If we watch the suboptimal thing that I showed you, or B, evolve, you might end up in something that looks optimal eventually. But it has to start suboptimal. You can't just optimize it to start. And in fact, if you let it evolve and you add pathways back in, you might get a different, so it might be continually suboptimal. You're just evaluating it locally. In terms of robustness, I don't know if there are other terms for robustness, but it's just this idea.
I was kind of pitching robustness as an alternative to suboptimal.
Right.
In the sense that it has suboptimal.
Yeah, and it requires it. Yeah.
But.
Well, I think robustness is the functional outcome. Yeah.
Right. And that's why it's better.
Yeah.
and then the other thing I just wanted to follow up with Brian is is work on mean field models of multi-agent training. So to leave it open and not be reinforcement learning all the time. But in a sense, like the centralized policy training algorithms are your benchmark, right? Like you should have, like we're just saying, like there should be a robustness in a decentralized collective intelligence that should be, in the proper scenarios should be better. And we talked a little last year just about multi-agent training and how to emphasize kind of the diversity, behavioral diversity in the multiple agents, and that partly that was coming from the centralization, or like you're kind of just training one agent at scale, right, as opposed to collective intelligence, or allowing for more independent evolution. And just kind of wondering how that fits in already, and does that help in terms of identifying metrics of the when's the collective better, or at least different, when's the collective decentralized algorithm giving me different results or different behaviors, and then leaving judgment aside of whether those are better or worse.
Different results from a non-centralized system.
Yeah. So right. So it's like if you imagine just perfect clones, right? So it's like perfect clones. What's the point of having diversity policy if they're all going to behave the same way, right? So it's like unless you have behavioral diversity, there's no benefit to the collective intelligence, right? Or like this is the like wisdom of crowds kind of thing, right, that you have that wisdom because of the diversity, right? Not only that, but the diversity plus the ethical voting. let's throw that in, just because we've got some political races that are being decided for the first time on new polling, new voting systems. So it's interesting, how much, when does that so the voting matters too, right?
Yeah.
Or the voting system matters too, in that allowing diversity to express.
Yeah. Okay. Well, that's very good. Thank you for that discussion. And Samantha had to leave, so thank you for attending, Samantha. So I guess we can, I don't know if we want to go over submissions. I just wanted to make some points about some of the things that are coming up. So let's revisit this document. Let me share my screen. Thank you again, Brian, for your presentation. Yeah. Okay. So our submissions, we kind of track these and kind of go through. So had a couple that were kind of outstanding. So this Bika AI conference, I'm thinking of submitting something by the 15th. That's the second round. I don't know if I'm going to get to that deadline or not. Probably. I'll try. But then this ABM Hub, which is something that was a paper. It was either a two-page or six-page paper. That's also due tomorrow. I don't know. Jesse was invited to submit something. I don't know if Jesse had time this week to do that, or it was in good shape to do that. But I mean, that's something that we had discussed in the Slack, but I don't know if it's like these things where they want a paper within like 2 weeks is very hard to hit that target. So if we don't hit it, we can do another venue. It's fine. They may, in this case, the ABM Hub, we might actually consider asking if we can extend that deadline or, express intent to submit something. They're usually pretty flexible in some of these workshops, depending on the, what they have, how many papers they have. So then there's the cognitive computational neuroscience, which is coming up. And there's also a May deadline for that, but later in May. So I think, and then of course we're looking at NeuroMatch 5 somewhere in fall of 2022. So I don't know if we have any other things we want to put on the list. I've been, I'm always looking at different things coming across my email or whatever, and I try to put them on the board. We also put them in the Slack, and I usually put them here. But if anyone has any things that they want to highlight or think that we might want to shoot for, I know there are always conferences coming up, but that's something that we need to kind of have a good, maybe a couple month leeway on, so that we can have something prepared. Oh, We Robot, yes. So We Robot was accepted, and that was something Jesse put in the Slack this week. We had 2 submissions. Yeah. So you want to say something about that, Jesse?
Mostly just what was in the Slack, and also that that's going to be kind of a turning focus ahead for some things. But yeah, We Robot was accepted. I don't know if that's like, do we make it green when we like finish submitting to it, or when it's been like we're gonna do it?
Oh yeah, well, I don't
know.
I try to. Yeah, I don't really have a very good or very consistent color coding. What do we make this? Where is it? We Robot. Here. Why don't I make this green for now, and then because we've got accepted. Usually it's green, and so that's okay. So that's accepted, and then that's where this is here. Okay. See, it's not very consistent. It's just.
Yeah, it's fine.
But yeah, okay, so that's good.
But yeah, there's 2 well, first let me go back to the one that was the invited thing. There was a lot of discussion in Slack about, this is great, we should do something. We're being invited to the did I put it in the we're invited specifically to the ABM Hub workshop. There's nothing that's happened with that so far. There's been a lot of interest stated, but last week I had no time. This week has not been a time for me to do anything. I know Daniela was interested. I was looking to that discussion again. I might ask them, just because I know we have. I mean, we could tailor a lot of things we've discussed even today, or other things related to the summer code.
Yeah.
But I might ask them for an extension just to see what they say. But I don't think I'm going to be able to. I'm certainly not going to be having a full page paper tomorrow.
Yeah, wouldn't work.
Myself anyway.
That's though, if you want to meet with me though, Jess, I actually would love to be involved in that paper, and I've talked to Daniela a little bit about it, but we both kind of had a very busy week last week. If they give us an extension, it's possible.
Yeah. I'll reach out to them about that. But yeah, if we do get a green light for that, I'm up for it for sure. So I guess I'll try to do that now. It was a very like, they emailed like, but not my main email, so it was kind of like, I think I'm in the records from a very like older thing. I'm gonna ask for something now. But as far as the We Robot stuff goes, that's definitely happening, and I'm very excited about that because the good thing, the awkward thing is that it's one of those things you apply, in, like you apply in the end of winter basically, and then at the start of fall you're presenting it. So it's strange to put things in that timeline in one sense, but in another sense we have a lot of time. I think between Google Summer Code and this VR shift that's gonna happening, I think there's gonna be a lot more discussion. At least maybe not dominating the lab discussions, but like things I'll be focusing on. Will be interesting to frame that. One of them is a bit more. One of our presentations, one of our submissions for We Robot is basically a little bit more. I don't really want to say technical, but like nitty gritty in a how do we try to get towards like shared cognitive interfacing stuff, which is an extremely lofty goal, and you know. And the other submission is much more kind of inspired by plot twisters and a lot of narrative focus and a little bit, almost a little bit more. It's kind of ethics society team, but also like how does an individual interface with that? And it would be, I kind of wish, I think Sam had left, but I wanted to kind of pitch it in a way to like, for those, I know Sadhna, I don't know if she was here earlier today, but Sadhna and Sam, was that?
No, she wasn't.
Sadhna and Sam, and even also a couple other folks have been really interested in like, you know, empathy and AI and things like that. And I feel like a slight twist on some of their focus, or themes they've been interested in would work really well with that project too. So I feel like I have to kind of I'm not sure if I should have this. I don't want to. I'll go into this a bit more after we talk about the full submissions document because I want to stay on track with that. But I'm kind of setting up a lot of. I have to set up a lot of sort of the research administrative structure to do a lot of these things ahead. So more about that to come. But We Robot, we have two things going on. One's a bit more like how do we deal with some cognitive stuff and putting it into be a virtual or augmented reality and track some things across that stuff. And then one of them is more of a personal experience in the personal experience in a world of many different. How do you manage your personal journey in a world that's full of different news sources and different pulls and pushes on your identity, and how do you communicate across those different forces? So it's a much more of almost like a very different flavor, but interesting. But I think I kind of want to almost craft some like internships or project descriptions around those things so people can know what they'd be focusing on as we go over the summer and that. But more about that later. I think that's enough.
Yeah.
On those top for now.
Yeah, I think that's.
I don't have any other. Yeah.
Oh, you don't have any more updates? Okay. Yeah, that's good.
I don't have any other things to talk about submission-wise. There's other things I could say about all that stuff, but
okay.
What were you gonna say?
Well, I think it's good that we kind of craft that around like recruiting people for internships because it gives them something to lock into. I mean, I think we've done a good job this time with kind of letting people find projects. And I mean, I think it's worked out. But it would also be nice to have people like, because I know we had at one time, had these cards, and we still have the cards, but it's sort of like, this is what we're doing, and then if you want to join into this project, and that works for some people, but other people want to have like a very defined thing to lock into. So I mean, that's a nice thing to have. Yeah.
And kind of on a similar note, I was obviously not here this morning, but it's kind of a general check-in. Like, the spring semester's over, so I don't know. I'm going to bring up in the Slack and here too, although most of the interns aren't present at the moment, but kind of getting a check-in from them about like, what do you want to be doing, and do you want to stay on through the summer and all these other things, because most people have been, no one's told me they explicitly don't want to do it, except for we had one person leave the lab, and I have to follow up with a couple other folks, but like it's kind of like I think it would be a great time to just, this is more like lab admin talk, but like a great time to say, hey, here's where the ship is headed. Here's what we have for like projects you can join right now. Here's what you can do right now, and here's broader things, because there's definitely there's going to be some really specific things that we could use help with, or that someone could just have like a project based around and they could do their stuff with. So I've wanted to do that a bit sooner, but then last week was just this black hole of stuff. So that's kind of what I'm looking at in that sense.
Yeah. So,
but I don't think there's any other submissions that came to my mind, but I feel like there's a bunch of other things. I know that Morgan put the Neurotech challenge in there. Is that an event or a?
It is an ongoing event, or I should say it's a challenge, and so that is open for participation, and yeah, let me check in with John before I speak to say anything more about it, just in terms of what its current status is. But it's something that was put together. We put together with OpenBCI and IEEE Brain, and if you've even if you don't have a system, I can show you where to get really cheap stuff off of eBay. And you could be collecting, a couple channels EEG paradigms that we've got, 32 channel data from, 128 data from, so it's great material for learning other machine learning algorithms. And in particular, obviously, this is awesome material for nonlinear time series analysis, which is somewhat my focus on it.
Yeah. So why don't we check that out or stay on top of that? Then I don't think there's anything else in those submissions. Like I said, it's again, it's like when we get opportunities, we can put them on, but I don't have anything that's immediate that we need to be aware of. So yeah. Oh, go ahead.
Only other things I would mention are, I know, and this is kind of not really, we don't really do things in this area, but just kind of bridging into stuff I'm doing with other groups. There's a big, like IEEE World Internet of Things conference coming up in June. There was another thing happening in June too, but I forget what it is. But there's a big IoT event that I may be going to, or like some semi-attending in June. And just to note, I think we've all discussed it here, but I don't know if it's really a submission thing, because I don't think we'll be able to submit to it. But just to confirm from a couple weeks ago, the AI debate 3 that was supposed to be kind of in May and maybe even earlier than that has once again been pushed back to apparently October. So that'll be. I hope they have a little more of a component, and I know they want to make things bigger and better there, but yeah, I kind of want to keep following tabs on that to see what they do with that. If there's any like actual more discussion or engagement as well. Like it's just a talk, but I wonder if they're going to do more with it. We'll see.
Yeah.
Excuse me. But yeah. So I don't know. Forgive me for not. I wasn't here earlier. I know we have like 30 minutes left or so now. What did you want to talk about, Bradley? Or I have some other stuff, but it's not really important.
Oh, I mean, yeah, we can talk about it. I just wanted to go over some papers, maybe, but we can talk about whatever it is you wanted to talk about.
Somebody posted, maybe Bradley, the Samsung AI. You mentioned Gary Marcus, the Samsung AI neurosymbolic meeting.
Oh yeah, that's
the Marcus made me think of it, or I think he's an invited speaker on it.
Yeah. When is that happening? Is that this Monday?
I want to.
No, it's in June.
It's June something.
Yeah. So let me see if I can share. Might as well go.
Registration is open
and share. Let's see, what channel was it? I think it was in data science, maybe, or. So in general, I can't remember where exactly I put it.
Yeah,
but it's
yeah,
it's Robot. Yeah, it's an event. So yeah, it's this. Okay, here it is. Event webinar. Go to webinar. So this is the registration form. Second virtual neurosymbolic workshop where deep learning meets logic, June 6th through June 8th. Okay, so this is a ways off, but if you want to, 2 p.m. BST, which is British Standard Time, so it would be like early in the morning in North America. Yeah. 7:30 Central Time. Okay. So I mean, that's good, and they've done a lot of stuff. I think they did one last year where they neurosymbolic. I don't know if it was sponsored by Samsung. I think it was like maybe Sony or something, but they always have some good speakers, and that's sort of the AI debate is usually between the neurosymbolic people and the people who say deep learning is crashing through walls. So that's something to go. Yeah, why don't we put that on? I'll put that on the submissions doc just to make sure that we have that available. Neurosymbolic workshop. And then that's just attend only. You don't have to submit anything for that. But it's always good. We've done this, and of course we do the shared notes documents. So if you're attending, we'll probably do a shared notes document where we have people will contribute their notes and put them in there, and we'll have like this huge list. And we've tried to figure out how to do this better, and there are things like Otter AI that would allow us to transcribe, but I think that's like a talk, if it's a video. But there are other things that summarize notes. So, but these are still good because you can go through them and see what was going on, and see people's thinking as they go through. I think I've done this a number of times with Jesse, where we've like made notes and they've been very different. I have different things to say than Jesse has to say, and it's it's always good to go through those different perspectives. Okay.
Yeah.
Can I just mention the learning salon this week? Yesterday, had Chris Summerfield, and just related. He let me just. So it was on Crowdcast, and I'll try and drop a link. But a paper that he dropped in at the beginning of the meeting is on, so it's a Josh Tenenbaum paper, Learning to Solve Complex Tasks by Growing Knowledge Culturally Across Generations. So I just wanted to add that as, okay, cool. Related to your collective intelligence, that this kind of cultural transmission and the kind of noisy communication channel, it seems also super relevant and super important. So yeah, just and they DeepMind has or Google or DeepMind has a new paper just recently where they're doing the same kind of cultural or the agents are doing there's no human involved. I think is like the tagline is cultural transmission, no humans involved or something.
Okay, yeah.
Is this related to like autocurricular stuff, or is this?
So it was cool because he mentions this paper, and it's they're learning a video game, and then they tell the next person who's gonna play. So you're supposed to you play the game, and then you try and give hints, give advice to the next player, and then they have like 10 players chained, right? Mm-hmm. So I hope I'm not mixing papers, but I think this is
it looks like it. It's learning robust real-time cultural transmission.
Yeah, so it's and thanks, Brian. I think Brian dropped the Crowdcast link. So I don't know how much he necessarily focuses on that particular paper, but I like to your collective intelligence one.
This is great. This is nice to see, and it looks like there's a cultural general intelligence team. So I don't know. That's like a consortium of some type.
Yeah, and so here's another cool thing is that there's an EG Notebooks connection to that particular group.
Oh, okay.
So Corey Matheson is on that group, and so there's three of them. I don't think they're twins, but there's like three brothers, and they're all doing amazing things. And so his other brother's at University of Alberta, and is doing cool computational modeling as well as cool neuroimaging. And it's like it's a really specialized optical imaging that tries to capture neuronal activity directly and not the hemodynamics. Anyway, but that's just it's a funny connection because I saw that too, Bradley. I was like, oh, there's a cultural cultural team, and then I was like, oh, there's Corey. So if you see EG Notebooks, the Mac version that had some TensorFlow stuff, that was written by Corey's brother.
Okay, yeah.
And interesting fact, he's also a stand-up comedian.
Also, okay.
the DeepMind guy.
Okay. Does he tell jokes about like DeepMind?
Apparently.
Oh, really?
Like I don't know. You need to go see his stand-up.
Remember, there was a paper like about 10 years ago where they tried to teach a robot how to do stand-up comedy, and it wasn't great, but it was funny. It was like.
I do, yeah. I'm sure we can find the ICLR workshop on teaching jokes, teaching agents to tell jokes.
Yeah. Were you going to say something, Jesse?
Oh no, sorry. I was...
Okay, so that's a nice because we talk about cultural revolution in the group or cultural transmission. It's interesting to see people kind of hitting on that a little bit more. There's a lot of space here, I think, for people to kind of explore, and Yeah, so maybe we'll do that maybe in another meeting here. But yeah, I think the collective behavior is really interesting, and I think that's something we want to unpack a lot more. So we'll have like data sets that we can look at like in open source communities, and then we'll also have simulations of open source communities. And again, it's that issue of like kind of defining the metrics. Sometimes you can have like data that you'll get, and sometimes it's pretty limited as to what it measures. And other times, you could do a simulation, but you have to define the parameters and sort of what things are representing. So, like, if you have an agent-based model, your agent is maybe a participant, but then what they interact with and how they interact has to be defined somewhat precisely, I think, to get a good answer. And you can use off-the-shelf simulations like, say, a prisoner's dilemma, or maybe something like a more exotic model like reinforcement learning model. But then the policies have to make sense. The rules, the payoff structures of the game or the rules that you use all have to make sense in this context. And that's I hope we kind of explore in our little group too. Is this sort of go ahead.
Just wanted to add to that the problem in like generative adversarial networks, the optimization problem.
Yeah.
It is, or they're supposed to work because you can find this mathematical point in your search space, right? But it actually has a lot of, or you want it to have some of those suboptimal properties, the landscape is really interesting, and not and just solving it and how that is solved and whether you've actually achieved that particular point is a big problem, and but super interesting, and the reason that I think it's interesting is that there's some cool math behind trying to solve it correctly, and how to do that. Like, there's an algorithm for it, but you can never determine whether you've reached it. So it's like a MCMC kind of thing where it's like, have you let it run long enough, right? So
right.
You can. The way to find your Grosvenor basis is Bookbooker's algorithm, and you just don't know whether Bookbooker's is completed.
Yeah.
And certainly some of the problems that have been raised, but with GAN, reproducibility problems and abnormal behavioral problems have been pointed out as really optimization problems of the game theoretic optimization.
Yeah. Yeah, I mean, this is great, great stuff. And yeah, I didn't even think about GANs, but that's actually, there are a lot of connections between game theory and GANs that, and of course, just using an adversarial approach to this might be interesting. But I don't, it's something that, again, you'd have to specify what you mean by what's your adversarial data set? Is it like bad actors, or is it like what? Right.
And that is also part of the interesting multi-agent kind of training problem. One, you're not you don't want all the players to be the same, but two, that there might be teams.
Yeah.
Right. And some of this was brought up by the fact that as a part of cognitive computational neuroscience meeting, there are adversarial collaborations are encouraged. So check out their websites. I forget what they call it, but they also find or see some productivity in properly structured adversarial interaction.
Well, yeah, that's like. Oh, go ahead.
Oh, I was just asking, who were the they? Was it
the cognitive computational neuroscience organizers?
Oh, okay.
Like check out the meeting. It's part of the meeting that they'll put this together. I mean,
yeah,
it's yeah.
Yeah, I mean, this is like interdisciplinary research, right? Like you have people who come, and I've done these sorts of things where you have like a computational person and like a biologist or a social scientist, and they'll talk, and the idea being that they're going to have different points of view on things, and if they don't talk, if you're trained in both, then you're an adversary to yourself, I guess. But if you're like only in one area, then it's like, okay, I think of the problem this way, you think of the problem this way. How can we bring our expertise together? And sometimes it may or may not, may or may not work. Sometimes it doesn't work. Oh, thank you for the link. And so that's what one of the things we have in the lab here is like, can we sort of optimize for interdisciplinary interactions as well? And so this is, again, this would be useful as a theme in this group. So this is the link to so they're accepting submissions. Is this, this is the generative adversarial collaborations. So this is, let me share my screen. This is really interesting. Where is it? Here it is. So this is May 31st. So this is something maybe we can target. I don't know. What are the most exciting challenges and controversies in cognitive computational neuroscience? How can we make tractable plans to solve them collaboratively? So this is actually just like a sort of a talk, I guess. This isn't necessarily where we have to have adversaries. But this, so this is kind of, applying to lead a CC and GAC.
Yeah, it's not... I remember when they changed the structure, but yeah, like it's like a discussion thing.
Oh, okay, a discussion thing.
This would be setting. It's almost like setting a workshop topic.
Oh, okay.
Yeah.
Do you need to have a lot of participants, or do you just need to like have a clear plan?
Yeah, it looks like. I mean, I get the feeling the idea is to the way that this would be different is that it's multi-year. Like you'd keep coming back.
Oh, okay. Yeah. Well,
I mean, it'd be answered by work covering 1 to 3 years. I don't know if that's they necessarily come back.
Right. Well, if it's good,
or if
I
it's
guess.
Just,
yeah.
That's the scope, but.
Yeah. So yeah, obviously, if it's to be answered by work covering 1 to 3 years, it could be that you're asking a question that you would then set like, okay, this is a goal. Like we want to write a grant that covers this work. They don't want people to say this is a 20-year goal. This is a 20-year process. They have this idea of different types of like. They have a moonshot, a Mars shot, and that sort of thing where you you have a sort of an effort that goes maybe to the moon, maybe to Mars, maybe out to the outer solar system. So it's like that sort of effort. But yeah, that 1 to 3 years, I guess, would be like maybe a Mars shot. I don't know.
If there's something that you think is somewhat aligned and just needs like some extra push, I'd love to submit something to that because it's here in San Francisco.
Yeah.
And I could at least physically represent the group. I can get in, and I'm vaccinated.
Oh yeah. Yeah. Okay, yeah, that would be good. We'll look into that. I'll put that on the list after the meeting.
And perhaps related to that, but just if there's other alternatives, I think Jesse had put out a call about this like many months ago. But if there are alternatives to Netlogo, or if there are packages that overlap in terms of functionality to Netlogo, or people do modeling, I can check out some of the Netlogo papers that reference it and see what other packages they talk about. But if anybody knows others, that'd be interesting.
Yeah, I don't think there's like an alternative. I think that they it's probably the best one for like agent-based modeling where you have different toolboxes. But there are I'm thinking actually that maybe there's a room for, and this is a longer term effort to build based on what we do with MetaBrain models in the group. And I know Jesse and I have talked about this, but having like a agent-based model where you have different layers. So you have different representations running sort of connected. So you'd have like a low end representation, and then you'd have a little bit higher level representation, and then an even higher level representation. So it would be like maybe a very simple rule, and then on top of that you'd have like some sort of decision making process, and then on top of that you might have a symbolic process, and then each agent would have this stack, and they'd interact, and it would allow you to look at things at different levels of interaction. It would be more sophisticated than the typical simple interactions you can see in a agent-based model. As for other types of specialized model, I think there are probably other options, like if you're looking to implement a specific type of agent-based model. And this is something that I wouldn't reinvent the wheel here, but there's always room for innovation in terms of implementing a model. So if there's a way to implement an agent-based model that's not, that's clearly better than Netlogo, that would probably be good to look into.
I'm just going to say, Stephen Wolfram has been reading his own book for the past a couple months, and what's cool, one, it's always fun when an author kind of goes over their own book.
Yeah.
But in particular, there's this is a book that's very much the complexity of agent-based models.
Yeah.
Of super simple toy problem agent-based model.
Right.
And it's been nice to kind of go back and I was saying that it was finally he managed to get me through the book.
Yeah. Okay. So why don't I move? Go ahead.
I was just going to say really quick before we lost this particular thread, although I know the meeting's almost over, but just that something that's nice about Netlogo is that there's so many examples available, and that it's mostly written in Java and Scala, so it's actually pretty easy to customize if we need to do that, and that it's, from a computer science perspective, it's the way that it deals with concurrency is really interesting. I've been really digging into that, but
so I didn't realize that Swarm is, I don't know, should I use the present tense? Swarm is all Java. As well. I didn't know. Was there a lot of overlap between those projects?
I'm not sure.
That's was Chris Langston?
Yeah, I think it's a different group, but I don't know. Maybe I don't know. People have crossed paths at some point.
I think it speaks to when the projects were initiated.
Yeah, I think Chris Langton hasn't been doing much. I think he's an artist now or something. But when he was doing stuff at Santa Fe, I guess it was that's when that happened. So I don't know how current that is or how it's kept up, but yeah. But it's there are a lot of options here. I think at some point, it just we don't want to reinvent the wheel where there's some easier way to do something.
it's always interesting to get a sense of like, so what exactly though are the algorithms that it's implementing?
Yeah.
Right, like how does that differ, and then just kind of going back to my earlier point, but just like what's the software now, or what are the packages now that I can play with for multi-agent training,
right.
multi-agent policy training, and so basically I think I want to know like how to what are the packages for building games these days, right? Yeah. I mean, like obviously, what is it, like Unity? The Unity developers like have their own, reinforcement learning research program, right?
Right. Okay. So why don't we move on to papers? I have a couple things I wanted to talk about. So the first one I wanted to talk about, I gotta share my screen though. That would be good. Okay, so the first one I wanted to talk about is this paper. This is something that we found in the Cognition Futures Reading Group. I think it was Brian who pointed it out. This is this paper, Morphological Coordination, a Common Ancestral Function Unifying Neural and Non-Neural Signaling. So this goes back to their idea of like basal cognition. And so basal cognition refers to cognition that happened sort of at the base of different clades, groups of organisms that evolve, or the tree of life. So we think about like, all the different variations on cognition that exist in, say, vertebrates. There's probably a stem vertebrate form of cognition. So it's like the first vertebrate that emerged. There was this cognition that it was engaging in, and then there was this diversification of cognition. In this paper, they're really interested in sort of in animal cognition. So like some of the earliest animals are the stem animals that existed. And so they're able to get into some of these non-neuronal models as well as some simple neural models. So what they're basically suggesting here is that they're reviewing evidence from evolutionary, developmental, and regenerative biology to suggest a deeper ancestral function of pre-neural and neural cell-cell communication systems. So these cells actually communicate with one another through signaling molecules, and those signaling molecules are pretty diverse. You have peptides, you have other sorts of paracrine signaling, you have endocrine signaling, you have these other mechanisms. And some of those relate to how maybe some of these early nervous systems worked. I think I talked about this in the Theorem group a while back, but I can't remember exactly which session it was. But in any case, this further allows a sharp formulation of the distinction between long-distance axis symmetry coordination based on external coordinates. So what was happening early on in nervous systems, and they give a bunch of evidence here from sponges and cnidarians and early bilaterians, which are organisms that have like a bilateral symmetry, and a lot of things like their proteins for synapses that get expressed in these organisms. There's also cell-cell communication based on peptides that would later become like more advanced types of systems in other throughout evolution. These things would evolve into more complex signaling systems. But what they're arguing here is that there's this shift between simple sort of movements, or what they call taxis, which are responses to stimuli. And we know this from our Bradenburg vehicles, that if you have a stimulus, like a light stimulus or a chemical stimulus, there's a movement towards that stimulus, and that's called a taxi, or chemotaxis, thermotaxis, whatever. That's a very simple form of cognition, and it's a response, a reactive form of cognition. What they're saying is that over time, you get this situation where you go from those sort of reactive taxis to sort of an egocentric form of cognition. So egocentric cognition is where you have sort of a coordinate system based on your body, and that you're moving around in the environment, just like you are maybe with reactive taxes. So you might, but instead of responding to the stimulus, like light stimulus or chemical stimulus, you're putting it into a reference frame, and you're able to associate different things in the environment. So this is an innovation in cognition that they're kind of talking about here. This is why the title is morphological coordination. So I don't know if there are any figures in this paper. They kind of talk a little bit about systems that are outside of the traditional way we think of cognition. This is a network with no closed paths. So this is kind of talking about network topologies and how those might be arranged. And I kind of get into some of this. So there's always, like, with this other non-neuronal work, there's always this postioc of different pieces of evidence. But I think the core of this paper is to suggest that there's this difference between sort of like these reactive taxis, reactions to what's going on in the environment, moving towards things, moving away from things, and then this sort of egocentric framework that, say, we use when we integrate stimuli in the environment. And we can integrate things in different locations, and we can put them in a spatial context. So this is something that you'll see a variety of different nervous systems. Some of them are still, you still today, you see extant species with these sort of taxis. So C. elegans, for example, does this. There are other, bacteria do this. You have other types of, multicellular collectives, single cell organisms that do this sort of thing. And then you have organisms that use their body as sort of the center of a frame coordinate system to associate different things in the environment. And so this is an innovation that they're suggesting happened in evolution, but this is sort of the scaffolding for a more complex form of cognition. Okay, so do you have any questions about that, or? That was age-based.
Just realizing that that's the same guy that did the active inference and quantum systems paper.
Oh, Chris Fields?
Yeah.
So the other paper I'm going to talk about, and this is a little bit, maybe, I don't know how over everyone's head this will be, maybe not. But I'm going to make this kind of simple. So this paper is Andreas Wagner, and he actually is one of these people who talks about robustness in evolving systems. So he's very theoretically oriented. And
big Evo Devo guy, right?
Yeah, Evo Devo. Yeah. And so this paper is neutralism and selectionism, a network-based reconciliation. So when we talk about neutralism, this is a term probably none of you have heard. Maybe Morgan, I don't know. So selectionism is this idea that evolution is driven by selection. So you have selection for things, and that's how evolution proceeds. So things get selected for, natural selection is dominant, and the way most people think about evolution. But neutralism is another option, and this happens when you have different things, when natural selection isn't very strong, when you have things that can change or can be fixed in the population through a multiple, you have multiple pathways to something, and those, there are different mechanisms for neutralism. So it's a different way of thinking about evolution, but it still results in evolutionary change. So I know that wasn't a very good description of it, but the paper kind of describes a neutralism here. So the abstract reads, neutralism and selectionism are extremes of an explanatory spectrum for understanding patterns of molecular evolution and the emergence of evolutionary innovation. So selectionism really suggests that there's one pathway that's selected for that is sort of almost like this optimization. So selection, strong selectionism says that they're optimal pathways that emerge through natural selection. Neutralism kind of argues maybe the opposite, that you get a lot of different pathways that are equivalent. and that there's neutral change. It could be through the population dynamics or something, but you get these different pathways, and that also is an outcome of evolution. And this is something that, if you want to look at evolutionary innovation, if you want to look at like the emergence of new traits, you have to understand kind of both of these extremes. And so, although recent genome scale data from protein coding genes argue against neutralism, molecular engineering and protein evolution data argue that neutral mutations and mutational robustness are important for evolutionary innovation. Here I propose a reconciliation in which neutral mutations prepare the ground for later evolutionary adaptation. So with neutral mutations, and this goes back to Mutu and Kimura in the 70s, and this is something that emerged sort of in molecular evolution. So what they observed was that you would have mutations that weren't really selected for, but they were generated. And then those mutations would contribute to the variation in the population. And in this case, what he's arguing is that these neutral mutations allow for later evolutionary adaptation. So he's combining sort of this idea of neutralism that allows for adaptation, and then maybe selectionism that allows for selection of these things, these options. Key to this perspective is an explicit understanding of molecular phenotypes that has only become accessible in recent years. So, as we've learned more about like how the genotype works and how that maps to phenotypes, and this is still a pretty theoretical area. We don't really have a very good idea of how genotype maps to phenotype, except in some very crude ways. So it's not something that's very well understood, but there are a lot of theoretical models that make this connection, and they have these things called genotype phenotype maps, which show the relationship between, say, like some archetypical gene and then some very simple phenotype. So people have done this with RNA phenotypes, and they've looked at what they call neutral networks, which are these hypercubes, and I don't know if he shows one in here, but it's basically this idea that in an RNA, and this is a very simple phenotype. It's probably the simplest phenotype you can have. I don't think they have it, but this is kind of, so this is kind
Amanda
of
basically.
What's that?
Amanda asked about genetic drift.
What genetic drift is, or
she said, how does genetic drift relate to this distinction?
Oh,
but it was
Amanda,
like
yeah.
earlier.
So yeah, genetic drift is similar. So the idea being that genetic drift is it fixes certain things in the population. It's a population process that fixes certain things. And Morgan, you were going to go ahead and say something.
No,
Oh,
I mean, let you finish.
Yeah. So your neutral process gives you these options, and genetic drift kind of pushes the population a certain direction, and you end up with this kind of change that's not selection, but it's this sort of neutral process. You were going to say something, Morgan?
I'm not sure I've got anything to contribute.
Okay.
It's certainly, just like you said, it's an old idea that the mass of alleles have no selective pressure.
Right.
And it's this idea, it's this kind of iceberg, it's this old iceberg idea that like you've got this mass that's moving, and I guess the drift is kind of your momentum of that.
Yeah.
Usually it comes up in the context of, some sort of geographical change, and then,
Right.
the drift is a separation, right?
Yeah.
Just to add that, like, other things that Andreas Wagner, that you could have adaptive gene misregulation as well, like just sort of speaking to this suboptimal.
Yeah.
How suboptimal is better. And that there's just a lot of interesting, I guess it is like Richard Watson was my wife's, master's advisor.
Yeah.
population genetics is a great simulation environment for learning systems.
Yeah. So so let's see, where were we here? It's different. Okay, here's the paper. So I don't think they show hypercube in here, but basically an RNA phenotype is sort of like the simplest phenotype you can have. And if you, I actually will draw something here. I don't mind if I do. We'll go to a new one here. And so if we have like a cube where we have, let's say this cube is like this, and the way usually these neutral networks are drawn out, you have like this cube, and each node has a state. So this is, I think 8 states, so you'd have 3 values here. So it would be a binary value of order 3, so it would be like this, 0, 0, 0 to 1, 1, 1. And the idea is each of these lines here is a mutation. So if you have a mutation here, this is 1, 0, 0, this is 1, 0, 1, and this is 1, 1, 1. So it could take a minimum of 3 mutations to get to 1, 1, 1. Now there's no selection on this cube, so all these pathways are equiprobable or equivalent. And you can move across this path, so you can move each of these possible paths from 0, 0, 0 to 1, 1, 1 involve 3 mutational steps, right? If you were to put selection on this and say, or even like genetic drift for that matter, and say that certain of these pathways aren't allowed, like this pathway isn't allowed, this pathway isn't allowed, this one isn't allowed, then how long does it take you to get to from 0, 0, 0 to 1, 1, 1? And it turns out it's still 3 mutations, but in some cases, if I had a hypercube, for example, which is a higher order version of this cube, it might take longer. It might take more mutational steps. And so this is kind of the idea of how, neutralism and selectionism kind of interact. So this actually talks about robust phenotypes in this case. So in this case, RNA phenotypes are basically this. They're basically reduced to these binary values, and there's mutational change is represented in the phenotype. But, with like human phenotypes or animal phenotypes, those phenotypes are much more complex. So you can't really characterize them using binary values. But this is a kind of theoretical work. So they use this sort of network model to kind of demonstrate these changes, although it's important to remember that this isn't representative of any sort of complex phenotype. But in this one, robust phenotypes can lead to rapid yet neutral exploration of sequence space. So the basic idea is that evolution is exploring the sequence space. All these nodes, get explored in this process. And so different organisms in the population are exploring different paths through these nodes. And so, genetic drift could constrain this network by splitting it in 2. So some organisms might get caught up in this part of the space, some might get caught up in this part of the space. And so that's a divergence of options for that population. And then, those 2 populations. And so that would drive sort of evolutionary change without selection. Or selection might take out a bunch of nodes over here. So your starting point is constrained, but then you end up exploring more space. And there are different ways to look at these networks, and this is over time. And it basically, what he's saying here is that a network with low robustness is less connected than a network with high robustness. So there are more pathways to explore in a high robustness system, just like I showed in the first Chalk Talk part of this meeting. That the more pathways you have, the higher the robustness of the system. And then these processes act upon these networks and change their shape. And then that in turn changes how organisms can interact in these networks. And these networks, putatively represent genotypes, but then ultimately they represent phenotypes. Those models are, kind of very abstract, but they give you a general sense of how this works. So, so that's, this is a very highly theoretical work. So again, this is an example here of cycles of neutral evolution and positive selection. So here we have this pathway that starts out up here. You have a neutral path that's just kind of like picked through happenstance, that, this is the way things happen. There's no selective pressure here. It could be that, you have genetic drift where some individuals form their own population and they have a certain path. Sometimes it's just random processes that influence this neutral process. And then, of course, there's a beneficial mutation. So one of these things in the genotype is selected. And so then that's selection, and then that's beneficial. And then that constrains the exploration space in this network. And so then from then on, it's a little bit more constrained. But you can see how these processes interact. And so again, it gets into a lot of technical terms like epistasis and other types of things. And this is actually an example of an RNA phenotype. So an RNA phenotype is, again, this, it almost looks like a gene sequence, but it has some geometry to it. It has a shape, it folds over, it forms loops. And then we can say that this sequence, if we just have it as a string, maps to this phenotype, which is like, has some geometry to it. So, if you mutate it, the geometry can change or change function. And so this is a nice, very, very simple model of a genotype to phenotype map, these RNA sequences. And so neutrality of mutations depends on the order in which the mutations occur. So if a mutation occurs at one point versus another point, it can change the function without necessarily explicitly being a selective process or an optimizing process. It just changes, and it changes the function. And then if that's not selected on, it gets passed down in a population. And if it ends up getting fixed in a local population through genetic drift, it can define, say, like some subpopulation by its just by fact that it's there and it gets fixed, and it's not selection. So yeah, so these are things. This is a glossary, and there's a lot of stuff in this paper, a lot of computational stuff, but also a lot of biological definitions. Yeah. So I'm not going to go any further into the paper than that. I just wanted to bring it up because I think it ties into what we were talking about earlier. And there's a lot more there to kind of unpack, but... Oh, Morgan, you're muted.
Yeah, I mean, just terrific work. These are simulations that he makes available.
Yeah.
You can play with, and and that I dropped a paper in bioevolution. I wasn't quite sure if that's the topic, but another Andreas Wagner paper.
Okay. Yeah.
Just speaking to the development of complexity, biological complexity.
Right.
And just to add to that, or certainly the RNA story. Another paper this week in Science on RNA protein origin of life questions and RNA protein synthesis, and for those interested.
Well, thanks for that. So yeah, if we don't have anything else, that's all we have for today. We have any other comments or?
Just that a general comment. I'm going to be doing some things in terms of like admin and structuring stuff. I just mentioned to Amanda about I think it may be interesting to get another specifically philosophy person or philosophy focused undergrad or something to kind of join our little team in that way. And Amanda was kind of open to kind of being part of that process. So
okay.
I appreciate that. And I know we don't always, there's so many different parts of the lab that we don't always focus on stuff, but I think I'm definitely interested in keeping sort of the philosophy analysis component going strong. So there's a lot of, if anybody, I feel like I have a lot of things. I feel like I've lost time from the last 2 weeks really. So if you're interested in specific projects, and I know like just for example, I know we met with Morgan. I did leave early, but we had office hours with Morgan earlier this week. And if anybody else wants to have office hours about what they want to be doing in the fall or in the summer and in the fall too, but you're welcome to do that, because we're kind of in a phase of transitioning semesters and planning out like the projects, the base of projects we want to focus on. Because a lot of times we have discussions here, but there's a lot of there's different trains leaving the stations at different times. Is what it feels like, and then how do we kind of keep all that moving? So, but yeah, great. I've had people reach out to me saying they're interested in XYZ or they want to do this in the summer, and that's great. So I think there'll be more. I think next week there may be kind of an administrative overview about things, because there's a lot coming in, and I think we're going to find out about Google Summer of Code too.
Yeah,
Also,
this week,
right?
this coming week, yeah. And
So,
so if you're not selected for
probably,
that, don't be discouraged, because it's competitive. But I think if you want to continue that work, that's fine, and we can, because that'll often lead to other things. We have other opportunities, so don't worry about it.
Yeah, there'll definitely be. It sounds like there's a lot of steam around that, a lot of energy in that direction. So that's great, and it looks like the Google Summer Code. There's the Wii Robot stuff, and there's a few other things that are kind of springing up too. But more about that next time.
Yeah.
But yeah, it's good to see everybody today, and